Space is supposed to follow rules, right? There's gravity, there's physics, there are laws that keep the universe predictable. But these 10 discoveries, they don't play by those rules. They feel like cosmic errors, glitches in reality hiding in plain sight. First, let's talk about the cold spot. Imagine a map of the entire universe showing the faint afterglow of the Big Bang. It should be pretty uniform, but it's not. There's this one gigantic region, 1 billion light years across, that's way colder than anything around it. It's too cold, too big, and too empty. Scientists have a few theories. Some say it's just a statistical fluke, a random supervoid with far fewer galaxies than normal. But other, more radical ideas suggest it's something truly strange. Could it be a scar from a collision with another universe? A cosmic bruise left on the fabric of space-time itself? Whatever it is, it's a chilling reminder that the universe has voids we can't explain. Next, remember the visitor that broke all the rules. In 2017, an object came hurtling through our solar system, and it wasn't a comet or an asteroid. It was long, thin, and tumbling end over end. Scientists named it Oumuamua, which means scout or messenger in Hawaiian. What made it so weird? It sped up as it flew away from the sun, but it didn't have a tail of gas and dust like a comet, which would explain the acceleration. It didn't have engines, it wasn't melting, and it was moving on a path that suggested it came from very, very far away. It was a messenger, but a messenger from where? Somewhere beyond our rules, a place we don't understand yet. Then there's the star that dims like something is crossing in front of it. It's called KIC 8,462,852, but everyone knows it as Tabby's star. This star's brightness dips in ways that nothing natural seems to explain. It's not planets. They would cause small, regular dips. It's not a cloud of dust or debris that would dim the light in a different way. Instead, Tabby's star's light can drop by a staggering 20% at random intervals. It's as if something massive, irregular, and opaque keeps passing in front of it. Some have even proposed the idea of a giant alien megastructure. While that's a long shot, the truth remains a complete mystery. Let's move on to the double pulsar that actually bends time. Astronomers found 2 dead stars, 2 pulsars, locked in a tight orbit around each other. These pulsars are incredibly dense and spin hundreds of times per second, firing out beams of radiation like cosmic lighthouses. We can detect these pulses, and they are so precise they can be used as clocks. But here's the wild part: their timing shifts. Every time their immense gravity bends the space-time around them, the pulses arrive at a slightly different time. This system is a perfect natural laboratory, proving Einstein's theory that time itself can warp, twist, and stretch under the influence of gravity. Have you ever seen a perfect ring galaxy? Meet Hoag's object. It's a galaxy shaped like a nearly perfect circle of young, hot blue stars surrounding a much older yellow core. In between the ring and the core, there's mostly nothing, an empty gap. Nature usually creates messy, spiral, or elliptical shapes through chaotic collisions and gravitational pulls. It doesn't typically draw clean, perfect circles. How did Hoag's object form? Was it a bizarre galactic collision? Is it 2 separate galaxies that just happen to line up perfectly from our point of view? We still don't know, but it hangs in space like a cosmic target, drawn with impossible precision. Now picture this: planets with no star. We've found them. Worlds drifting alone in the vast, cold darkness of interstellar space. These are rogue planets, thrown out of their original solar systems by gravitational chaos. They wander silently between the galaxies, frozen and lost. Finding them is incredibly difficult, as they don't shine with their own light. But we know they're out there, possibly numbering in the billions or even trillions in our galaxy alone. They're a stark reminder that not every world has a sun, not every planet has a home. What about radio bursts that repeat on a timer? Astronomers detect things called fast radio bursts, or FRBs. These are incredibly powerful millisecond-long screams of radio energy from deep space. Most of them flash once and are never heard from again. But one source, FRB 180,916, is different. It repeats, and it repeats on a perfect cycle, bursting for a few days, going silent for about 12, and then starting all over again every 16.35 days. It's like someone or something is turning a giant cosmic switch on and off with clockwork regularity. What could cause such a precise pattern remains one of the biggest puzzles in astrophysics. Even black holes are acting weird. Take the one at the center of a galaxy called GSNO 69. A black hole is supposed to be a point of no return, where gravity is so strong that nothing, not even light, can escape. But this one burps on a schedule. It erupts in sudden bright flashes of X-rays every 9 hours. It's like a cosmic heartbeat. The theory is that something, maybe a star's debris, is in a close, unstable orbit. Every few hours, a chunk of material gets too close, heats up to millions of degrees, and detonates before falling in. It's a strange rhythm coming from an object that is supposed to hide everything. Here's how we first saw invisible matter. Look up the bullet cluster. It's actually two massive clusters of galaxies that collided head-on at incredible speeds. When they crashed, the hot gas within the clusters, which makes up most of the normal matter, slammed into itself and slowed down dramatically. But astronomers used gravitational lensing to map out where all the mass was, and they found that most of the mass didn't slow down at all. It passed right through the collision. This was the first direct proof of dark matter, an invisible substance that interacts with gravity but not with light or normal matter. Gravity maps showed mass where no light exists. Finally, entire galaxies are moving toward an invisible destination. Our own Milky Way, along with thousands of other galaxies in our local supercluster, are all streaming in the same direction, toward a specific point in the sky. And they're moving much faster than they should be, based on the gravity of all the visible matter around us. Scientists call this phenomenon the dark flow. It's a hidden pull from something we cannot see, something that might lie beyond the edge of the observable universe. It's as if the entire cosmos has a secret destination, and we're all being pulled toward it. If these are the glitches and cosmic errors we've already found, what about the ones still hiding out there in the dark, waiting to be discovered? These mysteries challenge everything we think we know. They force us to ask bigger questions and look deeper into the unknown. They are the puzzles that push science forward. If you want to explore more reality-breaking discoveries, make sure to follow at Trend Burst Studio. Thanks for watching.